Hey guys, here is your video for 14.2. Last time we were talking about mean. Today we're going to be talking about median, which is another way to represent a set of data. And median is especially helpful when we have outliers because your mean is going to be pulled whatever direction your outlier is. Your median sort of ignores that. So there is an absolute situation when you would want to use the median if you have an outlier. We're going to want to use the median. So the median is the middle, the physical middle of the list. When I list them of least to greatest, it is the number in the middle. So if you have an odd number of numbers, an odd number of values, the middle number, that's your median. If you have an even number in your list, then you're going to end up with two numbers right in the middle. If that happens, then you just find the middle of those two numbers. So for example, if you have 12 and 16, the middle of those two is 14. So your median would be 14. So you just need to remember that you are ordering them from least to greatest. You can't just put them in a random order, because say you have a bunch of numbers between 1 and 20 and you put them in any random order. If the middle number happens to be 20, that's your greatest value. That doesn't represent all the numbers, right? We would expect our numbers to be mostly represent around 10, our average or so to be around 10. So make sure you order them least to greatest. So here we've got the data set that shows the weight of a group of students. So here's my list of students' weights. I'm going to order them least to greatest. I like to cross it out as I go. So if I skip one, whoops, there it is, I can see it. So I see 86 is my lowest, and then I see 97, and then I see 98, and then I see 109, and then I see 117. And I like to cross outside in. So two outside numbers, next two outside numbers, here's my middle number. So the median weight is 98 pounds. Here I've got 16 in my cylinder, 16 ounces. Here I've got 32 ounces. Here I've got 56 ounces. Here I've got 8 ounces, and here I've got 64 ounces. So I'm going to list them from least to greatest. So I'm going to say 8, 16, 32, 56, 64, and I'm going to cross outside in. My median value is 32 ounces. Now here, they're giving us 6 numbers. They're giving us an even number of values. So we're going to have 2 numbers that are exactly my middle. So if I list these out, least to greatest, I'm going to have 23 as my lowest, and then I'm going to have 28, and then 29, and then 34, and then 36, running out of room, and then 43. And I cross outside in, and here again, I've got 2 numbers that are in the inside. Now the difference between those 2 numbers is 5. So half of 5 would be 2.5. So I need a number 2.5 higher than 29 and 2.5 lower than 34. 2.5 higher than 39 is going to be, 29 is going to be 31.5. So the median age is 31 and a half. So here, again, you're going to list these out, and then you're going to find your 2 middle numbers, and then you're going to figure out what's the middle of those 2 numbers. I'm going to jump down here to number 5 because this one uses fractions. I want to make sure you see the fractions. So here, fractions, we can find numbers in between the fractions, right? You can either turn these into a decimal, but that's a little bit harder when you've got eighths because it doesn't go evenly into 100. You'd have to take it to the thousands. What I would suggest doing here is finding your common denominator and putting them all in a common denominator. So instead of 1/2, I'm going to say 4/8. And instead of 3/4, I'm going to say 6/8. So I have 4/8, 5/8, 6/8, and 7/8. So I cross outside in. Okay, so now here I have 2 in the middle. I don't want to say 5.5/8. We don't really use that. So what you can do is if you double that eighth to a 16, you'd get to 11/16. And we do want a whole number in our numerator and denominator. And same thing here, I could have made this 10/16 and 12/16. So right in the middle there would be 11/16. Okay. Now we could use dot plots to pull information from the dot plots in order to find our median. So if I list these out, I've got 0, 1, 1, 2, 2, 3, 3. So I just pulled the data out of that dot plot, listed them least to greatest, crossed my way in, my median is 2. Okay, here, same thing. I'm going to 1, 2, 2, 2, 3, 3, 4, 5. Cross outside in, and then what's right in the middle of 2 and 3? 2.5. So that's going to be my median. This one shows you exactly why we want to use median sometimes. If you were to find the average, the mean of this data set, all of these numbers down here would have their own average, right? But then this little guy up here, he's going to pull that average higher than it really should be. And that's not representing the whole data set. Most of our numbers are here. I would say my median should be, or my mean should be like right there around 2, right? But this guy is really pulling it up. So if you were to find your average, it's going to pull it up to 3.5. So when you have an outlier, you're going to want to use a median because you'll see it kind of like gets rid of that outlier, sort of pays no attention to it. So if I were to list these out, I would say 1, 1, 2, 2, 2, 2, 3, and 15. So right here, when I start crossing those out, boom, that 15 is gone. And I got 1, 1, 2, 2, and here the middle of those two numbers would be 2. That is much more representative of where my numbers are. This 15 is really messing things up. So the median, again, can sort of eliminate that outlier, and we really don't have to worry about it messing up our data. Which of the two measures of central tendency, the mean or median, better describes the data set? So again, here, that median better describes where my numbers are because that outlier kind of gets not paid attention to very much when we do our median. So I hope that helps, and I will see you guys later.